Welcome everyone to my YouTube channel. Today I will discuss about differential equation of class 12 exercise number 9.5, which is homogeneous differential equation. In my previous class I was discussed about variable separable. So today discuss about homogeneous differential equation. So at first you have to understand what type of differential equation is called homogeneous differential equation. Let's start with an example, like in your exercise number 9.5, number 1, x square plus xy dy equal x square plus y square dx. At first, we arrange the equation as dy by dx and x square plus y square, x square plus xy in this form. Here, at first we have to check whether it is what type of variable in this problem. There are two variables x and y. So at first we try to separate by variable separable method. So variable separate is not possible because if x and y are in product or divide form, then we can separate them. But in this case, here x square and x and y are in plus form or minus form, then we cannot separate them. So variable separable method is not introduced in this problem. Now we have to move whether it is homogeneous or not. So to check it, at first you have to take it is a function of x and y. Let f of xy is this x square plus y square, x square plus xy. Now multiply each variable with a constant, say lambda x and lambda y. So lambda square x square, lambda square y square, lambda square x square, x, lambda x and lambda y. Now we should common lambda square from the numerator, and there is also lambda square common from denominator. Then we get like this, lambda square cancel. Here we see that x square plus y square by x square plus xy, which is exactly the same of the f of xy. So we can write here f of xy. So when we multiply each variable with a constant, then we get the same function. Now we can confidently say that the differential equation is a homogeneous differential equation. In this way, we can check whether a differential equation is homogeneous or not. So multiplying by any constant, we get the same function, so it is a homogeneous differential equation. Now we have to solve this homogeneous differential equation. To solve a homogeneous differential equation, at first we have to let y equal to vx, then derivative both sides with respect to x. So dy by dx and uv. Here we apply formula of uv. So v constant, x derivative of x 1 and x constant, then dv by dx. Here we apply UV formula of derivative v plus x dv. At first v fix derivative of x1 and x fix and derivative of v with respect to x dv by dx. So now we replace it dy by dx by this one v plus x dv by dx x square and y square can be write v square and x square x and y in place of y putting vx. Now v plus x dv by dx, we take common x square 1 plus v square and x square also in denominator 1 plus v, x square cancel. Now x dv by dx equal to 1 plus v square upon 1 plus v minus v. Now x dv by dx taking LCM 1 plus v square minus then product minus v square. Here we cancel v plus v square and minus v square. Now x dv by dx 1 minus v upon 1 plus v. Now we can see here we can apply the variable separable. At first there is no way to apply variable separable, but now there are two variable x and v and easily can separate those variables. So here dv, so term with v should be with dv and term with x should be with dx. So 1 plus v upon 1 minus v with dv and dx or x should be with dx, taking integration and plus k as before. Oh, now we have to integrate this one. Taking minus from denominator, we can write v minus 1 v plus 1 dv and dx by x plus k. Now v minus 1, here we can write v minus 1 plus 2. So adjust the numerator and dx by x plus k. Now separate this fraction v minus 1 by v minus 1 dv and minus 2 by this. So minus 2 is a constant, so we can write dv by v minus 1, here dx by x and k, here minus integration of dv obviously v minus 2. So derivative of this term v minus 1 is 1, v with respect to v is 1, so we can write it as log of denominator, this also log of denominator mod x, and this also log c. Now we replace v with using this value of v equal to y by x. So replacing v minus y by x minus 2 log of y by x minus 1. Here log x plus log c minus y by x minus 2 log of y minus x by x. Here we can write log cx. So this is the final answer. You can simplify it more to get the result of book, but it is quite necessary, it is quite satisfactory, and this is also correct.